13.3, evaluate trig functions. Of any angle. So the first problems say to use the given point on the terminal side of an angle theta in standard position to give the 6 trig functions of theta. So standard position just means that it's basically with respect to the x-axis is how we're going to draw it. So they give you an ordered pair, 5, -12. And we're going to basically plot that point, but you're not like, you don't need to like draw a whole graph. You're just going to do something that looks like this. Make it look a little nicer. And then the point 5, -12 would be somewhere down here. And so that would be our triangle. Okay, it's always going to be touching the x-axis, not the y-axis. People get that confused all the time. So just make sure you pay attention to that. So 5 is still our x value. -12 is our y value. And then we have to find the other side, which in these problems, the book is going to call it r, but I don't really care what you call it. You're just finding the other side. Now, I don't know if you'll remember this from geometry, but this is a Pythagorean triple is what this is called. Do you happen to know what the third side is without doing the math? No? Okay. So this is a Pythagorean triple. It just is like a special triangle. A 3, 4, 5 is also a Pythagorean triple, but anyways, we'll just do it the normal way. So 5 squared plus, and since the negative is going to go away with it being squared, I'm just going to write 12 squared equals r squared. So that's 25 plus 144. So I'm going to have the square root of 169 is r. And because this is the hypotenuse value, it can only ever be positive. So even though I'm taking the square root and normally it would be plus or minus, this value can only be positive. So it'll be 13. And then I just need to find all 6 trig functions of this angle. So again, it's the one that's touching the origin with like the x-axis attached. So set up for all 6, just like we did 2 sections ago. So sine of theta is opposite over hypotenuse, so it's going to be -12/13. Cosine of theta is adjacent over hypotenuse, so 5/13. Tangent, opposite over adjacent, so -12/5. And then for these ones over here, we just flip them, so -13/12. And it doesn't matter if the negative sign's top, bottom, out in front, it doesn't matter. Secant, 13/5, and cotangent, 5/-12. Now, if the value hadn't been like a perfect number and we'd had a square root, we would still need to rationalize the denominator just like we did. Basically, now you're just finding everything yourself instead of them giving you the pieces, is really the only difference. Let's see, 8. The point -6, 9. All right, where is this one going to be?
Somewhere in the bottom left quadrant.
bottom left?
Top left side.
Top left?
Yes.
Everyone agree?
It's 1,
1, 2, 3.
All right, so -6 x value, +9 is the y value. Then I need to find the hypotenuse value. So r squared equals 9 squared plus 6 squared. So that's 81 plus 36. So r is going to be equal to the square root of 117. So now I have that piece of information, and I can do all 6 trig functions. All right, so sine of theta, opposite over hypotenuse, so that's going to be 9 over the square root of 117. But remember, we need to multiply by the square root of 117 over the square root of 117. So it's going to give us 9 root 117 over 117. Cosine, adjacent over hypotenuse, so -6 over the square root of 117. Rationalize it to -6 square root of 117 over 117. Tangent, opposite over adjacent, so 9 over -6, which reduces to 3 over -2. Then when I do the other ones and I'm flipping them, I'm flipping the original one so I don't have to rationalize again. So square root of 117 over 9. Square root of 117 over -6. And this one, I'm going to just go ahead and use the already reduced one, -2 over 3. Ten, 5, and negative square root 11. So where is this one going to be? Bottom right. So down there. So 5 is x, negative square root of 11 is y, and I need to find r, so r squared equals negative square root of 11 squared plus 5 squared. So negative's going away, the square root's going away, so I'm just left with 11 plus 25. So r is equal to the square root of 36, so r is equal to 6. And then just set it up. All right, what's sine of theta? Negative square root of 11 over 6. Cosine. Five over 6. Tangent. Negative square root of 11 over 5. So then what is cosecant? And if you want to go straight to the rationalized form, that's totally fine.
C
Don't forget the negative sign. That has to go with it. Secant, 6/5. Cotangent, -5 square root of 11/11.
So which angle do you choose to be the angle we choose?
Always the one on the origin.
Okay.
So it's always going to be that one. So if it was, draw each scenario for you. So, oh, it disappeared. Come back. So you could have this one. So this would be where they are drawn, and then this would be the angle that goes with each one. Oh, you can't see the last one. Gonna lose the there. Try to not lose the textbook and keep the iPad on the screen. All right, the next thing are quadrantial angles. And so those are all of the angles that occur on an axis, so either on the x or the y-axis. And so they work the same way. They still want us to find all 6 trig functions of theta for the quadrantial angle. So now they tell us that theta is equal to 0 degrees. So that's going to be this angle. So not fixing it. So that's going to be that angle right there. Okay, it's kind of hard to see. It's in green. So right here. So from the unit circle, what x, y value would this have? What's the ordered pair? What's the ordered pair on the x-axis? The easy one.
0, 1, 0.
1, 0. Now, we technically don't have our hypotenuse value, okay? We have the x, we have the y, we need the r. So r is equal to, or r squared is equal to x squared plus y squared. So r squared is equal to 1 squared plus 0, so r is equal to 1. Okay? Now, I don't know if this part was in your notes or not, but the sine of theta is equal to y over r. Cosine of theta is equal to x over r. And tangent of theta is equal to y over x. Okay? So when we set up to do all 6 trig functions, then sine of theta is y over r, so y is 0, r is 1, so this is 0 over 1, which reduces to 0. Cosine is x over r, so that's going to be 1 over 1, which just reduces to 1. And I'm just writing them out for y'all to see, but you wouldn't have to write them out for me like this when you're actually doing them. Tangent is y over x, so that's going to be 0 over 1, which is just 0. So now when I do cosecant and I flip the sine value, I would have 1 over 0, which is what? Undefined. Okay, undefined. Secant, flip it, it's still just going to be 1. Cotangent, I flip it, I get 1 over 0, which is also going to be undefined. All right. They don't, the odd ones are radians, the even ones are degrees, so I'm going to make up a radian one for you so that you can see what this would look like. Theta is 5 pi over 2. So 5 pi over 2 is bigger than 2 pi, so I know I've got to go around one full time. So I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So 5 pi over 2 is the axis, the y-axis, going up. So, I should ask this first. What is the coordinate values for the y-axis from the unit circle?
0,
0, 1. And it doesn't change because it's gone all the way around one time and it's back around, like it's going back around again if the values still stay the same. Get focused. So r squared is going to be 0 squared plus 1 squared. So r is going to be 1 again, which is always going to happen. So sine of theta would be what? Yeah, 1 over 1, so it's going to be 1. Cosine theta,
yeah,
0. It's going to be 0 over 1. Tangent,
0. Undefined.
undefined because it is 1 over 0. And then cosecant, secant, undefined, and cotangent, 0. So those ones are honestly probably more just annoying than anything because it's like 0, 1, and undefined all the time, but nonetheless we have to know them. All right, finding reference angles. This is probably one of the trickiest things in trig. It's not hard, but people tend to miss it for a variety of reasons. But it says to sketch the angle and then find its reference angle. So 16, negative 100 degrees. So the reference angle is going to be how far we have formulas for reference angles. Okay, you should have them in your notes. They are, go back. They're on page 868 if you need to reference them. And you don't have your notes in front of you. But it tells us in each quadrant what's happening. Okay. If we're adding or subtracting 180 or the angle or whatever. So with this one, this angle, we're going to sketch it first. So negative 100, that means we come down and around. If we come down this way, this is negative 90, a little farther, and we'll be at negative 100. So it'll be somewhere in this vicinity there. That'll be where that angle is, okay? So we are trying to find what they call theta prime. which is this value right here. Okay. Now, theta is this angle that I have in green. Okay. So theta is the positive angle that we need. If the angle was already positive, then I would just be using that. But since it was negative, I add 360 to that to find the positive angle. Okay, so negative 100 plus 360, so that angle is 260 degrees. Okay, theta is 260. So now I need to find what this blue angle is. Now, what I'm going to tell you is a lot of times the easiest thing is just to eyeball it and figure it out. But we actually have a formula. So in that quadrant, when we're finding theta, so in quadrant 3, the formula is theta prime is equal to theta minus 180 degrees. So this is why you have to use the positive angle, because otherwise we're going to end up with a negative angle. So this will be 260 minus 180. And so theta prime is 80 degrees. And that's what we're trying to find. So basically it's like, how many degrees is it from the x-axis is basically what we're looking for. When you don't know the formulas, it's like, what is happening? But eventually it just kind of logically makes sense. But it's going to take a while for it to get to that point, more than likely. People give me all different kinds of angles for a reference angle, and because they don't understand that it's like the distance from the x-axis, and so they don't understand how to find it. 18 is 320 degrees. So what quadrant would that angle be in? Okay, quadrant 4. So try to keep consistent with the colors here. This one's a positive angle, so I'm just going to go ahead and do it this way. So it's going to be somewhere down in here. I know that because this is 270. Yeah, 270. So I know that I'm going a little farther than that. So somewhere in this general area is going to be that angle. So this is theta. Okay, I'm finding theta prime. So I'm finding this angle right here. And it's going to be a positive value. So in quadrant 4, the formula is theta prime is equal to 360 minus theta. So this will be 360 minus 320. So it'll be 40 degrees is theta prime. Let's look at one that is done with radians. 20. We've got negative 5 pi over 6. So what quadrant is that going to be in? Quadrant 3. So it's going to be somewhere down here. Now, the angle itself that they gave us, okay, goes this direction, but that's a negative angle, okay? So I need the positives. This is where that coterminal stuff that we were doing really comes back into play. We're adding 2 pi to this number to get the positive angle. So I'm going to add increments of 2 pi. So 12 pi over 6 would be equal to 2 pi. So that means that this value is 7 pi over 6. So my theta, going this way, is 7 pi over, actually, let me do it this way, is theta. Okay, this is how it's all starting to build. But I need this angle here, which is theta prime. So in quadrant 3, okay, we already had quadrant 3 one time, and we had theta minus 180. Now it's going to be theta minus pi, because we're dealing with radians. So quadrant 3 for radians is theta prime is equal to theta minus pi. So it's going to be 7 pi over 6 minus, now, because I'm dealing with fractions, I need to have a common denominator, so I need 6 pi over 6 to replace pi, because that reduces to pi. And so then my reference angle would be pi over 6.
Wait.
You got it? Or are you confused?
No, I was like, because it was like in quadrant 3 earlier, it was minus 180, but now it's like minus pi.
Which is equivalent.
Yeah, I just, yeah.
Yeah, it's just a matter of if we're using degrees or radians. All right, one more of those ones, just because it's something a little different in the way that it presents it to you.
Can I come in and just take a look at your classroom?
Yeah, sure. It's a mess, but sure.
She does kind of everything.
Yes. Hi.
But, so that's why I said numbers can vary, so she'll have multiple subjects, and obviously they're doing math, so we're not going to stay in here long. Thank you for your time.
Yeah, of course.
So,
All right, 15 pi over 4. So this is much bigger, or, well, I say much bigger. It's bigger than 2 pi, right?
Yes.
Okay, so what might I need to do so that I'm only having to go around one time? Find what? That's what we did yesterday, or in the last section. How do I find an equivalent angle? What's coterminal? What would the coterminal angle to this be, or how would I find it?
Would you subtract 8 pi over 4?
Yep, subtract 8 pi over 4, because that's removing 2 pi. So minus 8 pi over 4 is going to give me 7 pi over 4, which is my new theta value, okay? So that it keeps me from having to draw my circle, or like my graph thing going around multiple times. Now when I put it on the graph, I can just go straight to 7 pi over 4. So we go, 7 pi over 4 is going to be down here. So here's theta. Reference angle then is this one, theta prime. Now, I know we already had a quadrant 4 problem, but the difference is for radians, it's 2 pi minus theta. But I need something that matches the 7 pi over 4, so I'm going to use the 8 pi over 4 minus 7 pi over 4. And so theta prime, my reference angle, is pi over 4. Now, if it was in quadrant 2, I'm just going to make a note of this. If you already have it in your notes, you don't really need to worry about it. But if you don't, then for quadrant 2, this was quadrant 4. For quadrant 2, theta prime is equal to 180 minus pi, or sorry, 180 minus theta, or pi minus theta. So if it happens to be in quadrant 2, that's the formula you would be using to find your reference angle. I'm going to try to finish this section, and then that way tomorrow you'll have, after the unit circle quiz, you'll just have time to work on problems. All right, the last thing says to evaluate the function without using a calculator. Any guesses as to what that means? What are we going to use? What's our best friend for the next
Unit
8
circle.
weeks? The unit circle. So you're going to need that.
So what to?
So 24 is going to be the secant of 135 degrees. So secant pairs with what? What trig function does it pair with? Cosine. The relation of secant and cosine is 1 over cosine is secant. So when I think about this, I'm going to think about this as 1 over the cosine of 135 degrees. So what is the cosine of 135 degrees?
3 pi over 4.
That's not the cosine, that's the radian value.
No. Yeah.
Nope, without a calculator, put those away. Instructions say without a calculator.
2 pi.
All you need to do is look at your unit circle.
2 pi over 2.
What?
Oh. Oh. Oh, I know how to do this.
I don't know. What I'm making.
Cosine or which values?
Negative
I don't know.
radical 2 over 2.
Yes, negative root 2 over 2, okay? The cosine of 135, so we come to 135 degrees. Cosine are the x values, so negative root 2 over 2. So I have 1 over negative root 2 over 2. Now when I divide by a fraction, I multiply by the reciprocal, so this would be equal to negative 2 over the square root of 2. But I need to rationalize that, so that would become negative 2 root 2 over 2, which reduces to negative square root of 2. So the secant of 135 is negative square root of 2. Uh, 26, the sine of negative 150 degrees. So with this one, there's a couple ways you can think about it. You can either count backwards on your unit circle. So you can count, so that's negative 30, negative 45, negative 60, negative 90, negative 120, negative 135, negative 150. So you can either just count backwards and then find the sine value, or we can do the coterminal angle and add 360 to get a positive 210 degrees for my angle, and then I can take the sine of 210 degrees. Either way is fine. So what would the sine of 210 degrees be? Yep, negative 1/2. That one's nice because you don't have to rationalize anything. Let's see. All right, just because I want you to see this, I'm going to do an odd one. 27, cosecant of negative 420 degrees. All right, so what trig function does cosecant go with? Sine. The relationship is 1 over the sine of negative 420 degrees. So again, you can either count all the way around backwards, okay, or we can find a coterminal angle, either a negative coterminal that's easier or that's like down as a value that we know, or we can make it a positive one. I would add 360 twice so that I can get to a positive angle. So negative 420 plus 360. It's going to be negative. Can't use your calculator.
I was taking it.
Because if you give me a decimal value, I'm going to mark it wrong. Not even going to check it. So negative 120 degrees. Okay, I can add another 360. Wait a minute, that's not right.
240.
This was 60 degrees. There we go. Negative 60 degrees. Add another 360. So that would be 300 degrees. So I can compare this to 1 over the sine of 300 degrees. So what is the sine of 300?
Ah,
So this is going to be 1 over negative root 3 over 2. Divide by a fraction, multiply by the reciprocal. Okay, keep, change, flip. So that's going to be negative 2 over the square root of 3, which will become negative 2 root 3 over 3. And so that is going to be the cosecant of negative 420. All right, so we looked at a secant, we looked at a cosecant. I'm going to also do another odd one so you can see a cotangent one. 29 cotangent of negative 8 pi over 3. Now, what do we associate cotangent with? Tangent, that's the easy one. So 1 over the tangent of negative 8 pi over 3. Let's just count backwards on this one, just because. All right, so I'm going to negative 8 pi over 3. So negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3, negative 7 pi over 3, and negative 8 pi over 3. So negative 8 pi over 3 is down here. So what is the tangent value? Square root of 3. So this is going to be 1 over the square root of 3, which rationalizes to root 3 over 3. So without even having to do math, I'm going to show you something. The cotangent values just flip with tangent. Okay, so this was square root of 3. This is root 3 over 3. The cotangent value here would be square root of 3. The cotangent value here is going to be root 3 over 3. And it will just stay 1 over here because 1 over 1 just flips. So, anyways, more just a fun fact for you. If you don't get that, then don't worry about it. Just do it this way. All right, any questions about any of that? I know it's a lot of new information. All right, then problems. Three, 5, 7, 15, 17, 19, 23, 25, and 31. So tomorrow after you take the unit circle, usually people are done in less than 30 minutes. You'll have whatever time is left to work on these problems. Tuesday we'll do the retake of the unit circle if needed. If you all do really well on it tomorrow, then you don't have to retake it. And then Tuesday will be a review for a quiz on Wednesday on 13.1 to 13.3.